All right, welcome to our fifth week of Survey of Contemporary Mathematics. This week we will be in chapters 10 and 11. We're going to begin to review rational numbers, and we'll also start our unit on algebra. So I hope that this video will be helpful as we review some of this material, and I hope these examples will help prepare you for your apply assignment this week. The problems that I've gathered tonight are going to come from the end of the chapter review, so you might find some of these problems at the end of chapter 10 and 11. All right, so beginning with number 1, the first question asks us to find the opposite of these numbers. So if I was looking for the opposite of 22, that means what is the opposite sign? I know you don't see it here, but if you don't have a sign in front of a number, it is understood to be positive. So the opposite of 22 would be negative 22. If a number is negative, you will see that sign in front. The opposite of negative 4 is a positive 4. And it's understood to be a positive, so you don't have to put the plus sign in front. Okay. As we work with integers, positive and negative whole numbers, we'll need to be careful to watch our signs. Of course, if you're working with a calculator, a lot of this can be completed in that, but I'm just going to kind of review some of the rules for adding and subtracting with positives and negatives. What I tell my students, well, actually, let me just come over to the side and do some review with adding positive and negative numbers. So if I had 3 plus 5, of course, that's 8 because both are positive. They're going in the same direction. You just add and keep their sign. But if I was adding 2 negative numbers, we would add those numbers and keep their sign. So what I tell my students, same sign, add and keep, okay? But if your signs are different when you're adding integers, in this case, you're going to subtract them and you'll take the sign of the higher number. So 5 minus 3 is 2, but because 5 is a bigger number, it's negative. My answer would get that sign. And then I'll do one more example. If I have negative 3 plus a positive 5, signs are different, so we still subtract. We take the sign of the higher number. 5 is bigger, so the answer is positive. So in my class, we say same signs, add and keep, different signs, subtract, take the sign of the higher number, then it will be exact. That's what we do when we are adding and adding integers together, okay? In this example, we're going to be doing some subtraction with integers. and before we actually work with the numbers, I tell my students, leave, change, opposite. Rather than subtracting numbers, we're going to add the inverse. So instead of minus, I'll put plus, and then we do the opposite sign of that negative 2, and we get a positive 2. So that I can just follow the rules that I just discussed over here. So leave, change, opposite. It's not the same as leave, change, flip. That's what we do when we divide with fractions. But when we're subtracting integers, we will leave, change, opposite. Leave, change, opposite. So add the inverse. So different signs, subtract, take the sign of the higher number, then it will be exact. I'm just going to bring down the rest of that problem. Okay, work in the next step. Here's subtraction again. So we're going to leave, change, opposite. We'll add a positive 10. Signs are different. So we subtract and take the sign of the higher number. And then finally we have that minus 3. 4 minus 3 is going to be 1. So I don't know what kind of calculator you're working with. Be careful because minuses and negatives are not necessarily the same function on a calculator. So if you're working with that, make sure to use subtraction and a negative sign appropriately. Okay, this next example, I have 5/8 minus 5/6. Rational numbers are any numbers that can be written in fraction form. Even an integer can be a rational number because we can put that over 1 and make it a fraction. So why this unit's called rational numbers, because counting numbers, natural numbers, whole numbers, integers, those are all types of rational numbers. They're any number that can be written in fraction form. So here I'm trying to subtract these rational numbers, I have to have a common denominator, which we learned about in previous lessons. I would want to find a number that both 8 and 6 would divide into. That would be 24. You could just list those numbers, 8 times 1, 8 times 2, 8 times 3, and so on. I know that 8 times 3 is 24, so I'd have to multiply that numerator by the same value to get an equivalent fraction. 6 times 4 is 24, so I have to multiply the top by that same value to get an equivalent fraction, and then we subtract. 15 minus 20 would give me a negative 5, and the denominator stays the same. Okay, so just make sure that that negative is included in the fraction somewhere. You could put it on top, or I'm sure in Excel it's just going to be hovered out front, but you may have to use your apostrophe, to keep that in fraction form, but make sure to include that negative in your answer when it is meant to be negative. Okay. Decimals, okay. Just going to apply those same rules we were doing just a minute ago with the integers. When we're adding decimals, signs are different. So we're going to subtract and take the sign of the higher number. So that would be 1.65. This is bigger, so my answer is positive. And then I'm going to take 1.65 and subtract 1.44 from that. Not that I'm trying to encourage you using a calculator, but I know that you used it throughout this whole course, so just be careful that you don't take for granted that you know how to do this math correctly, and of course you can use a calculator to check that work. All right, next I'm going to be multiplying some fractions together. Negative 2/3 times 6 over 11 times negative 22 over 25. Okay, of course when I multiply fractions, I'll multiply all the numerators together, and I can multiply all the denominators together to get my fraction, but we always want to reduce that to lowest terms. But it might be beneficial for me to try to reduce these fractions first and then multiply. Okay, so what I mean by that is we can always reduce fractions up and down or diagonally. Okay, if there's anything that could be reduced diagonally, we can do that first. So either you can multiply and reduce, or you can reduce first and then multiply. So here's what I mean. 3 will divide evenly into 3 and 6. It'll go into 3 one time and into 6 2 times. 11 will divide into itself once and into 22 2 times. So just reducing diagonally, I've got numbers that would be easier for me to multiply together and perhaps may not even be needed any further reducing in the end. So I've got 2 times 2 times 2, which is 8. Okay, 1 times 1 times 25 is 25. Notice I had a negative and a negative. When you multiply 2 negatives together, that makes a positive. Okay, when you're multiplying negatives, you might have some that have several negatives in the problem. When you're multiplying an even number of negatives, 2, 4, 6, 8, your answer will always be positive. When you multiply an odd number of negatives, 1, 3, 5, so on, your answer will stay negative. So here I had 2 negatives. They multiply together to equal a positive. We'll look at some more examples with those signs in just a little bit. Okay, number 6, we are comparing less than or greater than. Please make sure you understand which one is which. This is the less than symbol, and this is the greater than symbol. Well, I have a lot of students that get those confused. Me. All right, so I'm comparing 0 and -3. Okay, you can think about how these numbers would appear on a number line. Okay, 0 being neutral. Okay, as you move farther to the left of 0 towards negative infinity, the smaller the number actually is. As you move to the right from 0 towards positive infinity, the bigger that number actually is. So even 0, is not, you think of it as nothing, but it's still greater than -3. I like to, encourage my students to think about money. If you're in debt to someone, that's worse off than not having anything. So just compare it that way. That helps. So once again, I've got -45 and -15. The bigger the negative, the smaller it actually is. Okay. So -45 is less than -15. Okay, we're going to review some with absolute value. The definition for absolute value is the number that digit is away from 0 on a number line. So like, for example, if I had the absolute value of 5, I know that 5 is 1, 2, 3, 4, 5 units away from 0 on the number line, okay? But if I was comparing that to the absolute value of -5, 1, 2, 3, 4, 5, even though I'm going in the negative direction, -5 is still 5 units away from 0 on the number line, okay? So because we're measuring distance, the absolute value of anything is always a positive. So it doesn't matter if there's a positive inside the absolute value, it equals that positive value. Or if there's a negative inside that absolute value, it equals a positive value. It's the distance that number is away from 0 on the number line. I'm just going to work backwards here. If I had the absolute value of -2, that would equal +2. If I had the absolute value of -4, that would equal +4. If I had the absolute value of +4, that is still +4. It's the distance that number is away from 0 on the number line. Now, the only thing I would encourage you to be watchful of is what if there was a negative outside the absolute value? Well, working inside the absolute value of -6 is a +6, but if there's a negative in front of that absolute value, you would have to bring that down with your answer. It's not meant to trick you, but it is different from these previous examples. All right. Find the quotient of these numbers. Remember, quotient is the answer to a division problem. I'm going to come over to the side and review how to multiply and divide with positives and negatives. We talked about this just a minute ago. When you have an even number of negatives, okay, let's say I was multiplying -3 times -18. That's going to equal a +54. Okay, when we're multiplying same signs, whether they're both negative or both positive, we get positive answers. But if I am dividing different signs, excuse me, let me finish that. If I am multiplying one negative and one positive, see how there's just one negative sign there? My answer would stay a negative. And it doesn't matter which one is negative. As long as the signs are different, your answer will be negative. So multiplying same signs gives you a positive answer. Multiplying different signs gives you a negative answer. And like the rule before, when I am multiplying an even number of negatives, I get a positive. When I'm multiplying an odd number of negatives, there's just one, I get a negative answer. Okay. So let me review some division rules. They're basically just like that, okay? They're not any different. If you are dividing with two negatives, your answer would be a positive. Just like if you were dividing with two positives, your answer would be a positive. But if you just have one negative, it doesn't matter if it's on top or bottom, just one negative, your answer will stay a negative. So those are the rules for multiplication and division with positive and negative numbers.
Jeez.
All right, so let me go back to number 18, or number 8. It says find the quotient. So that means I have to divide, and I have to divide in that order. -18 divided by -3. Two negatives make a positive. 18 divided by 3 is 6. You can type that in your calculator. It will confirm that. Negative 18 divided by 0 is not what you think, okay? We actually cannot divide by 0. So this answer would be undefined, okay? Now that's different from this last one. 0 divided by anything is 0. So I want to really caution you on these two that you don't get them mixed up. When 0's in the denominator, your answer is undefined.
That's only 0, right?
Only when 0's in the denominator.
Okay.
If 0's in the numerator, it'll equal 0. But we can't divide by 0. Some of your calculators, if you tried to do this, might give you an error because it's not possible to do that. All right, we're going to review scientific notation next. This is a way to either write really big numbers or really small numbers. We would put it in the form a times 10 to the nth power. Okay, this is a way we write really large numbers or really small numbers, and it is used in the sciences in some way. I know physics teachers use this quite a bit. So a has to be a number between 1 and 10. It can equal 1, but it has to be less than 10. N is the exponent, and that value will be based off of how many places in the direction that I move my decimal point, okay? So starting with this first example, it's obviously a really small decimal number. So I have to move this decimal over until I get a number between 1 and 10. If I stop here, 0.397 is too small, so I'm going to go over one more space. So that A, that number out front, will be 3.97. I want to include all those digits, okay? These zeros up front don't matter, but the non-zero numbers here do, 3.97. Times 10, now I've got to figure out what that exponent is. And that's based off of how many spaces I move that decimal. That's 1, 2, 3, 4, 5. Because it was a really small number, okay, that exponent's going to be a negative. Okay. Whereas this is a really large number, 12,345,000. When you don't see a decimal, it's understood to be at the back of every whole number. So I'm going to shift that decimal over until I get a number between 1 and 10. I can't stop there. 12 is too big, so I'm going to go one more space. So I've got 1.2345, include all those numbers, times 10. Okay, so we shifted over 3, 4, 5, 6, 7. So that exponent's going to be a positive 7. It was a really big number, okay? So ultimately, if I were to take 7 tens and multiply all of those tens times this decimal, I would get this number back. Whereas here, if I took 5 tens and divided this decimal by those 5 tens, I would get this decimal point back, okay? So it's just a way we can write really small numbers or really large numbers. When I shift my decimal to the right, that gives me that -5 right there. Shifting my decimal to the left, because it's a big number, that gave me that positive exponent. You may have to go from scientific notation to a standard notation, or maybe your book calls it a decimal notation, but this is putting it in a standard form, like an actual number. Because this exponent is a positive, that means this number is going to be big. So I've got to take that decimal and move it over 1, 2, 3, 4, 5 spaces. I'll fill in those empty spots with zeros. So that's 2, 4, 1, 2, 3, 4 zeros. That would be 240,000. You can check that. This is 10 times 10 times 10 times 10 times 10 times 2.4, okay? It's a large number, so scientific notation is a way that we can write really large numbers or really small numbers. We put that in the form of a times 10 to the nth power, where a is a number between 1 and 10. Okay, 11 says find the temperature after a rise of 18 degrees from negative 22 degrees. So imagine this, we're at negative 22 degrees below zero. We're rising, okay, so we're adding on 18 degrees. Notice what I'm doing here. I've got a negative 22 plus 18. The signs are different, so we subtract. Take the sign of the higher number, then it will be exact. So that's going to be negative 4 degrees after going up 18 degrees. So we're not even back to normal yet. All right, I'm going to work a couple of word problems before we get out of chapter 10, and then we'll get on into our algebra lesson. All right, number 12 says, to discourage guessing on a multiple choice exam, an instructor graded the test by giving 3 points for a correct answer, -1 point for an answer left blank, and -2 points for an incorrect answer. How many points did a student score who answered 38 questions correctly, answered 4 questions incorrectly, and left 8 questions blank? So going back to my information, 38 questions were right, and those are 3 points each. Plus, 4 questions were incorrect, and that was at -2 points each. 8 questions were left blank at -1 point each. So when I do this multiplication and add my numbers together, I'm going to figure out what the student's score is. So 38 times 3 is 114. 4 times -2 is -8. 8 times -1 is -8. So using order of operations, we're just working left to right. 114 plus -8. You're going to subtract and take the sign of the higher number, so that'll be 106. 106 plus -8, you'll subtract and take the sign of the higher number. So that's going to be 98. Okay, because we're adding a negative means we're taking off a -8 or taking off 8. Adding a -8 means we're taking off 8. So that's the student's final score there. That problem may come in handy as you go through your apply this week. Let me go over one final example from chapter 10. It says the boiling point of mercury is 356.58 degrees Celsius. The melting point of mercury is -38.87 degrees Celsius. Find the difference between the boiling point and the melting point of mercury. Okay, difference means subtract. I'm going to take 356.58 degrees minus, that's a -38.87 degrees. I've got to find the difference, but notice I'm subtracting a negative. When we subtract, okay, instead we add the opposite. So I call that leave, change, opposite. You add the opposite sign. So I'm going to be now, I've got same signs, we add and keep. That's going to give me 395.45 degrees. Okay, so just imagine this is over 350 degrees above zero, plus this is over 38 degrees below zero. So when you consider, you know, those, that's a greater gap than either of those numbers alone. So that's why we have to combine them there. Difference means subtract, but when you're subtracting a negative, that's the same as adding the opposite. All right. So we're going to move on into chapter 11. We're going to try to review as much as we can. I want to go through as many examples of solving equations. I'll start with some of the easier ones and we'll build our way up to the more challenging ones. Maybe it's been a while for some of these algebra topics, but I want to get in as much of the review as I can to prepare you guys for this week. All right, so in this first example for chapter 11, it says to simplify. We want to give it in simple terms as possible, okay? Now, according to order of operations, it would tell us to work inside that parentheses, but A and B are not like variables. There's nothing you can do to subtract those. The most we can do is take this -2 and distribute it, multiply it, times everything on the inside. -2 times A is negative 2a. Negative 2 times negative b would make a positive 2b. And that is our final answer. Some of these problems that we're simplifying may not come down to a neat and tidy little answer, but we just want to put it in as simplest terms as possible. And that is all we can do for that problem. Okay? Now, simplifying and solving are two different problems, okay? We're going to see a lot of these examples and in our apply where it may say simplify, solve, solve. So make sure you understand the difference between those. Let me go ahead and work this one and I'll come back to number 2. When it says solve, I want to know what does x equal? What does 1x equal? And I'm not done with this problem until I've isolated the variable that I'm asked to solve for. So to do this, we have to use inverse operations. We have to do the opposite of what's happening to that variable. X is being subtracted by 3. So the opposite of that would be to add 3. You see how negative 3 and positive 3 make 0, and now x is the only thing left on that left-hand side. But whatever we do to one side, we have to do to the other. Negative 7 plus 3 gives me negative 4. So that's what it's going to look like to solve an equation. You're going to find what that variable equals. It's much different than just simplifying an expression. Okay, so we'll be going back and forth between several of these kinds of problems. In number 2, the question asked, is negative 2 an answer for this equation? Okay, they're giving me a number and I want to know, does that solve this equation? So all I have to do is substitute negative 2 into the place of x, and I'm going to check and see if the left side equals the right-hand side. So all I've done is just substitute negative 2 into the place of x. Doing my math, I get negative 6 minus 2. I'll leave, change, opposite there, same signs, add and keep. I will see that the left side equals the right side, and so it checks. So on a question like that, we would say yes. That is the solution to the equation. If you are working in a calculator, remember order of operations, 3 times negative 2, and then you can subtract 2 from that to get your solution, to simplify that to see if it checks, okay? Okay, number 4 is another solve. I want to know, what does x equal? I like to draw a line through the equal sign so that you see there's a left-hand side and a right-hand side to this problem. Whatever you do to the left, you have to do to the right. My ultimate goal is to find out, what does x equal? So x isn't going anywhere, but the numbers, we're going to transfer them to the other side by those inverse operations. Adding and subtracting undo each other. Multiplication and division undo each other. Squares and square roots undo each other. So x is being multiplied times negative 2, then added to 5 to get negative 9. So I basically work order of operations backwards. I'm going to save that number with the variable for last. So instead of plus 5, I take away 5. Negative 9 minus 5 would be negative 14. I'm going to bring down that negative 2x. Now it equals negative 14. This is the same as negative 2 times x, and the opposite of multiplication is division. So x would equal, with that division, a positive 7. Negative 14 divided by negative 2 is positive 7. And of course, you could check your answer, to see if you got it correct by plugging it back into the equation and seeing, does this equal negative 9? Negative 2 times 7 is negative 14, plus 5 is negative 9. So you don't have to check it, but it's a good way to know if you got your answer right. Five asks me to evaluate a square minus b. Okay. I am also given the fact that a is 2 and b is negative 3. Because I now know what those variables equal, I can substitute them into this expression and simplify. So a squared would be 2 squared minus 3b, that's minus 3 times negative 3. So we can perform order of operations to simplify this down. 2 squared is 2 times itself, that's 4, okay? Negative 3 and negative 3 multiply to be a positive 9, and 4 plus 9 would be 13. Okay, so that one, we're substituting numbers into the place of the variables, and we're able to simplify that problem down as far as we can go. Number 6, we've got negative 3 times x equals 27. The opposite of multiplication is division. So I'm dividing 27 by negative 3, and that will equal a negative 9. Just going to keep working just a variety of equations to give you some to compare as you work this week. This one involves a fraction. Okay, but just think of this the same process as we did before. X is being multiplied times 2/3 and then added to 3. Save the number with the variable for last. To undo that plus 3, we minus 3. Same signs, add and keep. That'd be negative 12. Bring down the rest of that problem. Okay, so I've got a fraction that's being multiplied times x. Let me show you a couple of different ways we can work this problem. Okay, so just like before, we were multiplying times x. The opposite of multiplication is division, yes. Okay, so I can divide both sides by 2/3. But think about what that's saying. Negative 12 divided by 2/3. That's dividing with fractions, which we've already learned we leave, change, and flip in order to do that math. That would be negative 36 over 3, which equals negative 18. Negative 12. Did I copy that down right? 6 divided by 2. Okay, sorry about that. 1 times 2 is 2, and that gives me negative 18. Okay, so we leave, change, flip. Negative 12 is the same as negative 12 over 1 times 3/2. Negative 36 divided by 2 is negative 18. If you understand that method, you can do that. Okay, an alternate way to do this, when you have a fraction in front of your variable, okay, our goal is to get 1x. We just want to find what does x equal. Anytime you have a fraction, you can multiply that fraction times its reciprocal, and that will just completely cancel out and give you 1. But whatever you do to one side, you have to do to the other. See how these are the same steps taking place right here. I get negative 36 over 2, which is also negative 18. Okay, so either of those methods can work as long as you find one that you can work with. A number times its reciprocal, and the reciprocal is just a flipped version of that. 2/3, 3/2 equals 6 over 6, which is just 1. A number times its reciprocal is equal to 1. All right. Number 8, look at the word again, simplify. Okay, so I may not get an answer like these last ones, you know, an actual number. I'm just simplifying it to lowest terms. I cannot subtract inside this parentheses because these are not like terms, but I can distribute anything, okay? You can multiply anything. They do not have to be the same. So that would be negative 6x plus 4. Negative times a negative is a positive. And then we want to come through here and combine like terms. 3x minus 6x would be negative 3x, and then we'll bring down that plus 4. But that's going to be my final answer. Like terms have to have the same variable and the same exponent. So constants, numbers without variables, do not combine with the coefficients that have a variable with them. The next one says solve again, so we're actually going to find out what x equals. Notice on this one, though, I've got a variable on both sides of my equation. So what I always encourage my students to do to help avoid the confusion is get the variable on a side together first. And I usually move the smaller coefficient. Negative 3 is smaller than 6. So we would still do inverse operations. The opposite sign cancels out here, but whatever you do to one side, you do to the other. So that makes 9x minus 9 equals 36. And now this problem is very similar to some of the ones we've worked before. We're going to keep going, save that number in front of the variable for last. So the opposite of minus 9 is plus 9. So that gives me 9x equals 45. Opposite of multiplication is division. So x equals 5 from that. You can still check these. You would substitute 5 on this side and this side and see if the left side equals the right side with your work. Notice 10 says solve again, so I'm trying to get down to an actual answer. What does x equal? But notice here there's a lot going on in a problem here. I really should not have more than 2 terms on either side at a time. So I'm going to need to do some cleaning up over here on the left-hand side, and I can do that by first distributing and probably combining like terms. So that will be 3x minus 6, and then we have a plus 2. We can combine like terms here. Negative 6 plus 2 is negative 4. And I'll bring down the other side. Okay. So this is a lot like, some of the previous problems we've done. Save that number in front of the variable for last. So I'll add 4 to 11. That gives me 3x equals 15. The opposite of multiplication is division. So x equals 5. This may be our hardest lesson yet. I understand it's may have been a while since some of you have done some of these algebra skills. So, take the time to go back through your textbook and pull some of those examples or problems. Normally the odd are in the back of the book, so you could try a couple of those odd problems and check your work if you need to get some more confirmation that you're doing it correctly. Okay. All right, number 11 says simplify again. So we're just going to be trying to get it down as far as we can take it, okay? But we may not get an exact answer like these that have been solved. Notice these are all like terms, BC, 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 BC. So we're just going to work through here. 6 minus 7 is negative 1. Plus 2 is positive 1. Minus 5 is negative 4, okay? When you combine like terms, your variables, your exponents for those variables are staying the same. You're only adding or subtracting those coefficients out front. 6 minus 7 plus 2 minus 5. That gives me a negative 4. But you'll keep the same variables. I don't know that we've worked one yet, but let me just come over to the side here and talk about what would happen if I'm actually multiplying, distributing a variable times a variable. Okay, in that case, not only do we multiply the 2 and the 3, but I would add those exponents together. X times x makes x squared, and 2x times 5 would be 10x. But those are not like terms. This is x squared. This is just x to the first power. Those are not like terms you would just leave the answer in that form. All right, I'm going to finish up chapter 11 with some word problems. If you're watching this video later, our code word tonight is solution. You can email me a brief summary of the code word to receive your extra credit points. All right, number 12 says find the Celsius temperature when the Fahrenheit temperature is 100 degrees. Oh, I'm sorry, this did not copy correctly. So the formula is F equals 9/5 C plus 32, where F is the Fahrenheit temperature and C is the Celsius temperature. If necessary, we're going to round our answer to the nearest tenth, okay? So what we've been given here is the Fahrenheit temperature is 100. They've just told us what F is. So I'm going to be able to substitute 100 in the place of F, okay? And the question asks, find the Celsius temperature. So I'm going to be solving for C. I'm solving this just like a regular equation. Instead of X, I have a C, but I'll work it just like we did number 7. Okay. If it bothers you that the 100 is on the left-hand side and the variable's on the right, let me just say right now that it is okay to flip that whole problem over and rewrite it this way. Maybe you prefer that. A lot of my students do. Okay, so I'll work it this way. So we're going to save that number in front of the variable for last. We're going to subtract 32 from 100. So 9/5 C equals 68. I showed you 2 methods when you have a fraction in front of your variable. You can divide by that fraction, which ends up multiplying by the reciprocal, or you can just simply multiply by the reciprocal on both sides, which is the step I'm going to do because I want 1C. And to get that, 9/5 times 5/9 cancels to make 1. But that means I've got to multiply 68 times that 5/9. Okay, let me get my calculator for that. So I've got 68 times 5 divided by 9. There's going to be my decimal. It said round to the nearest tenths place, so I need to look at the hundredths, 5 or more, bump up the score. So C is going to equal 37.8 degrees Celsius. Let me go over a few vocabulary terms in case you've forgotten this. We've gone over a couple of them already tonight. This problem says to translate the total of n and the quotient of n and 5 into a mathematical expression. I just want to remind you that sum, S-U-M, means the answer to an addition problem. Difference means the answer to a subtraction problem. Product is the answer to a multiplication problem. Quotient is the answer to a division problem. You'll also see, maybe some different keywords used. Total, implies that I'm adding some things together. So you'll have some questions where you have to translate them from words into a mathematical expression using numbers, symbols, variables, whatever they include. So the total, that means I'm adding something. What am I adding? N, okay, and the quotient of n and 5. So I'm adding n plus the quotient of n and 5. Now you do not have to do anything with that, okay? We're simply translating it from words into that expression. When we're dividing, order really matters. We've talked about the commutative property already. Addition and multiplication are commutative, and it doesn't really matter what order you add or multiply in. But dividing and subtracting is not commutative. So it is not the same to have a fraction of 5 over n. We cannot swap the orders of adding and subtracting. You'll have to be very careful to put those in the correct order. We've just got a few more of those to finish up. 14 says to translate the sum of 5 more than a number and 1/3 of the number into a mathematical expression. Just take your time, read it a couple of times if you have to. We said sum means add. So what am I adding together? 5 more than a number is being added to 1/3 of the number, okay? We do not know what the number is, so we have to use a variable to represent that number. You can use any variable, x, okay, n for number, whatever you prefer. But I'm adding 5 more than a number, so n plus 5 or 5 plus n because it's commutative. That's being added to 1/3 of that same number, okay? So I'll keep the same variable. So the sum of 5 more than a number and 1/3 of the number. This is my expression, and I'll just leave it like that. These next two are similar, but we're going to take it a step further because after we set it up, it actually asked me to find the number, so I'm going to be solving this one. The difference between 9 and twice a number is 5. We've learned in previous chapters that usually in mathematics is means equal to, so this has an equation. Difference means subtract. So I'm subtracting 9 and twice a number. That means 2 times a number. And it is 5. So the difference between 9 and twice a number, so order matters with subtraction, it is 5. So we've got to find that number. All right, so be careful here. We need to save this number in front of the variable for last, but 9 is not negative, 9 is positive, so I've got to take it away. Don't ever look behind a number to decide what to do. Always look at the sign in front of it. If you don't see a sign, remember it's understood to be positive. So that gives me negative 2n, don't lose that minus sign, equals negative 4. And if I divide by negative 2, I get n equal to positive 2. Now what's important about this kind of problem is if you set it up incorrectly, you'll get an answer, okay, but it won't be the right answer. You've got to set the problem up correctly in order to get the right answer for that problem. 16 is just like that. We want to actually find the number. Is means equals. The product, that means multiply, of 5 and a number. So 5 times a number is 50. That's an easy one. 50 divided by 5, that would be 10, okay? So be able to set it up correctly. Sum is add, difference subtract, product is multiply, quotient is divide. Got one final problem. There is more than one way to work this question I'm about to read, okay? I'm going to use the method that the textbook shows, okay? So you might look back at chapter 11 and find an example like this as a guide this week. It says a tablet PC is on sale for $392. This is 80% of the regular price. Find the regular price of the PC, okay? We do not know what the regular price is. Okay, so I'm going to use what's called an original, change, and new ratio box, okay? You can find this in your textbook. So we're going to have a column for the percentage because it included percentage. It's a percentage symbol. And our actual values, okay? So this original price, okay, would always be 100%, okay? If you're paying the original price, you're always paying 100% of that. But it says it's on sale, and the regular price is actually 80%. So you're only paying 80% of that price. That meant there was a change of 20% taking place. There was a 20% discount somewhere along the way. Okay, the tablet is on sale for $392. Okay, that's the new price. But the question asks, what was the original or regular price? So see how I have used this original change in new ratio box to set up this information. We had to know originally every item is 100%. Now they might mark up and we could add on to get our new price, or that could be a discount and take away like we've done here. So after everything is filled in, I'm going to have to use these sections that have complete information, okay? So I've got 100 over 80 equals X over 392. And we've learned in a previous lesson how to solve proportions by cross multiplying. 80 times X would equal 100 times 392. And just as we've seen in this lesson today, we'll divide by the number in front of the variable to find out what that original price is. Now, obviously, this answer better be more than what the sale price is. And when I divide that, it is $490. That's the original price. You're only paying 80% of that, which gets you $392. Like I said, this is not the only way to work this problem, but there is a problem in your apply where this may be the best method to use. So I wanted to give you an example to follow. So thank you for participating in our Zoom tonight. Please email me, reach out if you've got any questions as you move forward this week.